Welcome. This is another Tactical Technician video brought to you by Diagnation. Today's a case study involving a 2015 GMC 3500 with a 6-liter gasoline engine, coil near plug with a check engine light on, and getting to this vehicle, hooking up a scanner, I pulled a code PO300, which is a random misfire. And right after that, I removed two of the fuses. I removed fuse 44 and 45 from the underhood fuse box, which are the fuses for the coils and the injectors for bank 1 and bank 2. So I got it so I can crank, and I did a relative compression test. I'm not going to show you the relative compression test, but I can tell you the relative compression test was good. The cranking cadence from my ear was normal and good and healthy, and the waveform looked good. It was anomaly free. So the next thing I did, as I had those fuses out, I put fuse buddies into the 44 slot and the 45 slot, and I put a low amp clamp around each of the fuse buddies. So that's kind of like the pattern you see on the scope now. The red channel and the green channel are the low amp clamps on the fuse buddies. So what those fuses do, one fuse would feed 4 injectors and 4 coils on one bank, and the other fuse would feed the other bank. So I also used a COP wand, a COP wand, on right next to the number 1 ignition coil as a trigger to look at the fuel and the spark. As you can see, I actually inverted this right here in blue. That is our trigger. That is cylinder 1 firing. The firing order on this engine is 18726543. We have misfires. One thing I'm sorry I failed to tell you earlier. After I pulled the code, I actually went to data. I went to misfire data, and I saw misfires starting to ratchet up on cylinder 7 mostly, and a little less on cylinder 5. The other 6 cylinders did not show misfires. So anyway, I failed to mention that initially. So basically, right after that, I did the relative compression, and relative compression, as I said, proved out to be good. So now here we are with this waveform, knowing that according to the scan tool, we had misfires on 7 and 5, and the engine did have a roughness to it, had a hitchy feel to it. So here we are on cylinder 1 here, and we'll go across the firing cycle. This is a 18726543, 18726543. So being that we see misfires on 7 and 5, we'll look at, let me look at the number 7 coil. So I got 187, this is the 7 coil. Now we have some difference in size because I'm using 2 amp clamps, which I later will switch to 1 amp clamp, and it may be a better idea. But anyway, our 7 coil looks good. We don't look shorted. We see good good oscillations here. We see a good little 187. Our little downward tail is pretty good, not excessive. Right here. So I guess that as far as the signal, the primary signal going through that coil, I'd say it's good. The 7 injector, I don't know which one is the 7 injector. If I saw an anomaly within these injectors, I would have set a trigger up on injector 1 and determined to look at the 7 injector. But looking at all the injectors here, I don't see any abnormalities. Nothing shorted. How does our current our pintle hump looks good here. So I decided, just for my next capture, I wanted to make it a little cleaner. So I went and I removed 1 amp clamp, and I put the other amp clamp on both fuse buddies at the same time. And we'll see. That's probably a really better way to do it. You know, I just thinking about it. So here we go. Now I have 1 amp clamp on both fuse buddies, so it's more uniform. We don't have the variable of 2 different amp clamps with ranges and batteries and stuff like that. And I want to point out something that's kind of interesting here. Here we go. Here's our waveform. Here's our trigger in blue. Here is our here's our pattern. So the high ones are the ignition coils. okay, on green. That's ignition. The low ones are the injectors. And it's a lot easier with 1 amp plant because everything is sequential in this situation, you know, because the ignition and the spark is sequential. Um, so we look and we don't see any abnormalities in any of the cylinders, whether it be injection down here or ignition up here. But I want you to notice something that kind of, maybe you'll point it out. Just look at it, even if you want to freeze the video from what I told you about our cylinders that are misfiring, and maybe just kind of analyze it. And you may come up with something, and again, you may not. It's just something interesting that you're always learning with scopes. And we know we have cylinders misfiring on 7 and 5. And right here is our capture. Here's our trigger on 1. So we go 1, 8, 7. Look at that gap here to here. 1, 8, 7, 2, 6, 5. Another gap here, and then 4. And then I'm sorry. 1, 8, 7, 2, 6, 5, 4, 3. After 7 and after 5, we have extra time. I have to say that the fact that the misfiring cylinders are causing the crankshaft to slow down, I find that kind of cool. But nonetheless, even worse on 7. There's more distance on 7 than there is on 5. But nonetheless, let me see that again. 7, 1, 8, 7, 2, 6, 5. Yeah, well, about the same. But nonetheless, you can see the gaps are extended. That is most likely the fact that when a crankshaft slows down, it takes more time for the events to happen. This on the horizontal plane of any scope is basically like a clock. That is time. I just wanted to point that out. So my next diagnostic decision, I thought about, do I flow test the injectors? You know, because this is just basically a command here. This doesn't prove that fuel's getting, you know, through the injectors into the cylinder. I thought about something, and I went back to the scan tool and I looked at fuel trim, because fuel trim is so powerful and it's so quick and unintrusive to gain information about what's going on. So I had the Snap-on Verus up, and I just sort of deselected the PIDs, and I picked 4 PIDs. I picked long-term and short-term for both banks, and I could see a diametrically opposed fuel trim. I could see one bank was plus and one bank was minus. The plus bank was plus 20, and the other bank was minus 5. Now they say the bank with the negative fuel trim is getting less air. So then I started to think about, well, this thing may have a plugged exhaust, and I wanted to prove that out. So the next step was to put a WPS 500 in cylinder 7, which is closest to the end of the engine, closest to the converter on that side. And I want to take a running test. Then I want to put the WPS in, I'll say a cylinder on the other bank, maybe 4 or 6 or 8, nonetheless. But here's my set. Here, when I went into side 7, here's what I found. Just want to make a point that on this coil near plug system, I didn't have to remove the coil to get to the spark plug hole. So if you get a situation like this, just be mindful that you want to suppress the spark. Don't let that dangling little 10-inch coil wire just dangle there, snapping its spark anyway, because it could affect the transducer or something. But always put a spark tester on the end of that wire to suppress the spark, or ground it or something. But here's our capture of sort of idling right here. Then I gave it some gas. I gave it my right foot about right here. And right where the pattern gets thick, take a look at our pressure. Take a look at our back pressure right here. This is bank 1, okay? Let me see that. Let me go back to here. Okay, right here, this is bank 1. We got about 23 PSI. That's a lot. That's a lot of back pressure right there. I'll granulate it in so we'll see it more. But nonetheless, let's first look at the idling back pressure right here and see where that is. This is the exhaust plateau, and it's idling, and it doesn't look too high right there. It's kind of got that, they call it the Bart Simpson look right there on top. We're looking about, that's about 1.2 PSI, but I'm more concerned when I give it throttle. So I'll go back to this area right here when I gave it my foot, and you could see our plateau is right, the highest plateau. Let's pull her down and analyze, and let's see what we got. as far as back pressure here. We got, wow, that's about 20 psi. So that's something to deal. That's definitely back pressure. What I learned about when you give a car throttle with a transducer in the cylinder, this should sort of, you shouldn't see this high point here. It should sort of smooth out. You will see some very minor valve action, but not like this. This sort of screams the exhaust is plugged. That's a high plateau here. So now we got that catalytic converter under suspicion as being plugged. Let's make a comparison for the other bank. That would be bank 2, and see where that was. So we were about 21 psi there. And let's go to the good, I would call it the good converter. I wouldn't say this converter was perfect, but nonetheless, we're going to see a difference. It's coming up. Okay, let's, okay, right here, right to our thick red spot. Let's run the cursor, the horizontal cursor down and see what that is. Right at the top of the red. Okay, that's a lot less. We're looking at about 7.6 psi. That isn't ideal. I can say without any doubt that this converter is not perfect either as compared to bank 1, but nonetheless it's better than the other. So we got we got a diametrically opposed amount of air flowing through these banks, but nonetheless, I'll kind of open in on that one. Let's look at that that plateau. That's about the highest one. About right here. Okay, that's about 10 psi. Well, yeah, 10 or 11. That's less, but it's still not perfect. It's a lot less than the other banks. So obviously that would explain the inequality in the airflow and hence the fuel trim and the misfires on bank 1. I have to deem that the misfires on 7 and 5 are being caused by excessive back pressure. I'm going to recommend a converter, and I'll probably make a follow-up video once I get if I'm able to, is to get a post converter installation capture and see what we got. Anyway, this is a technical technician from Diag Nation signing off. Thank you very much.